Hi, I'm Ben Johnson. Welcome to our first Schmiedmann technical video, which we hope our YouTube followers can get some good information and knowledge of exactly what we do here at Schmiedmann. This car today has come to us from a customer. As you can see, the wipers are going on their own. I haven't switched those on. And now we need to work out what's wrong with this car. There are various check control messages for electronics failure. We haven't looked at the fault codes yet. We're going to save that for the camera so we can actually see for the first time what the fault codes are. But first, safety first, we need to take the watch off, and also we need to disconnect the fuse for the wipers so that they don't wear out, and they're also quite irritating. So let's do that right away.
So as you can see, we now have a set of wipers stuck in the middle of the screen. Not very attractive, but at least they're not going all the time. I achieve that by simply taking the fuse out. Now what we need to do, our ignition's on, our battery support is on, so we're not draining the battery and causing unnecessary damage to the customer's battery. Our seat covers are on, steering wheel cover, gear stick cover. Now let's do a quick test with our amazing Autologic tester, which we'll cover a little bit more about at the end of this presentation. We start with a quick test, which we're going to actually now see all the possible control units fitted to the vehicle and any possible errors. Quite a fast machine. I like to use it because it gets me what I need and gets it fast. Now we're going to interrogate the junction box electronics. Is our main suspect unit because from past experience with the wipers going like that, other than the DSC brake system, which can also cause that, and also the DDE or the DME engine control units, they can also cause the wipers to go like that. However, there are other messages, CC messages, with regards to body functions, body electrics, so I suspect that to be our main issue. And there we see the park distance control, no communications whatsoever, and also the junction box electronics. Now, it's very interesting to see that on the modern cars such as the F10, the PDC is now integrated within the junction box electronics. In the older BMW models, of course, it's in the trunk area, and in my opinion, much easier to diagnose, much easier to access. Very simple. But no problem, we've already stripped our glove box from the car in preparation for the next step, which will probably be scoping to look at the signal of the KCAN2 communications board. First of all, let's look at our faults. If we go to next on Autologic, you see faults in absolutely every system on the vehicle. This may not be physical faults with those control units, but maybe because the signals required on the bus from the junction box electronics and the PDC are missing, so they will also display fault codes. But we can communicate with everything else. The only thing we cannot communicate in the car with is junction box electronics and PDC, so we'll focus on those. Primarily the junction box because the PDC is kind of built into it. So everything else is communicating. Doesn't have this, no faults with that. Great. Now then, what we need to do is go back and we can view the full fault report from Autologic. Air conditioning system, instrument cluster, roof function center, engine control, DSC, many things on there we can look at. I'm quite satisfied looking at that we have no faults in these units. We can disregard those, of course. Notable information on Autologic, as you can see, is junction box electronics and PDC. Quite satisfied that we can delete those faults once we find the problem, and we only need to concentrate on one area, which we're going to do right now.
So now we've established we need to look at the junction box electronics as our primary failed unit or a wiring issue. We know we've got a CAN issue. We've just set the scope up with reference to this wiring diagram. This is, as you can see, the main connector, which what we do, we take these off so we can access and back probe, not front probe like some people have done, which damages connectors. We must back probe them. And from that point, on pin 1 and pin 2, we will get a scope trace. CAN high and CAN low. That's the communication lines. We suspect there's an issue with one or both of these, which is why we don't have any communication to our junction box electronics. It's a very simple wiring diagram. There's not really much to really show here. We only need to focus on one thing. Okay, we can of course focus on checking the fuse, which when we scroll the diagram across, we have one power supply and one ground supply. There's no need to go into that in this video, we've already checked those. We have 12 volts and we have a very good ground with no voltage drop on the ground or the live. Simply we used a fluke meter to test that. It's beyond the scope of this presentation. We now know we have power and ground at that unit, so it can only be either the unit is faulty or the bus lines are faulty. We will now go and look at the oscilloscope trace and then commence the next step in the fault finding procedure. As we look at the screen here, we have an oscilloscope set up on a dual channel with a common ground to the vehicle. As you can see, the red signifies the CAN high and the blue signifies the CAN low. And I can tell you by looking at that, that's definitely not what a CAN bus signal should look like. We have a problem here. The junction box electronics contains the terminating resistor, which means usually on any other partner control unit on a branch line, we can disconnect that control unit and see if we have a stable signal returning. That can then show we have a faulty control unit or we have faulty wiring. However, on this unit we can't do that because it has a terminating resistor in it. So we could have one line which looks like we have a problem on the blue line, and the second line seems to be working, but it's not balanced because the terminating resistor now is probably open circuit on the blue line. Remember, it's a 60 ohm resistor. This pattern could signify we have 120 ohms, which means one is open circuit. And since they're in parallel, we divide them so we get 120 ohms when we have a problem. Now we've already measured that prior to the video to make the video a bit easier and a bit shorter. We have got 120 ohms. So now what we need to do is look on the wiring to find, is there an issue with the wiring? Is it shorted to ground? Is it broken? Incidentally, we've also disconnected the control unit before this scope trace was set up. And the terminating resistor in the control unit is measuring 60 ohms, which actually means the resistor is okay. So in theory, the control unit should be okay. Sometimes there is a problem with the control unit. But we're going to focus on just inspecting the wiring harness next and see if we can find some sort of a problem. It's not uncommon to find issues, wiring rubbing through. Previous retrofits were Basto systems, for example, disturbed wiring, maybe they could chafe through. And let's hope on this car we can find something quite simple and restore the operation of the vehicle for the customer. So, the good news is we've actually found our issue, which I'll show you shortly. As you can see, things like this on the ground point, somebody at some point has retrofitted something, I don't know what the hell it is, but it's obviously not BMW original. So that gave me a clue that obviously this could be not a factory issue, but some sort of aftermarket retrofit. For example, there is some sort of, seems to be for a traffic camera, for insurance purposes, which has actually been retrofitted in. But it doesn't go anywhere near that harness. This is our oscilloscope backpinning probe setup. We have the CAN high and CAN low there, and we have it grounded to the common chassis ground, a good ground point there. The reason I'm holding the carpet back is just to demonstrate where this problem was. They follow the harness back from here. The main harness then goes this way. As you can see, it's quite large, and it goes to all the other partner control units on the bus system. And the problem is with this, is that somebody at some point has done something wrong, damaged the wire, and over the years, the moisture and corrosion has got into that wire. And this is just a section that we've chopped out here. And as you can see, it's dirty, it seems a little bit burned actually, but there was no evidence of that. And we basically make a good cut each side, and we've put in a very low resistance repair connector. And now the next step is going to be to plug our wiper fuse back in and hope that our bus system is now restored, which we can now send an oscilloscope trace. And we can see from here if it sends a good signal to the scope from our setup, and we can erase all the faults on Autologic, then we hopefully have fixed the problem. We just need to build this up to a good standard so the customer doesn't have any issues with
with things like this that we've had to remove, and those scratches, and make sure we look after everything. Put it back to how it was, basically. So the next step, we switch my lovely useful lamp off, and we'll see if we've got a good oscilloscope trace, and then secondly, we'll see if we can erase the fault codes, and if there's any basic settings that need to be set back up, time and date for example, we'll do that, and hopefully the customer will get the car back today with a minimum of around 2 to 2.5 hours diagnostic time spent, as opposed to maybe some other people with a bit less experience. It might take 8, 9, 10 hours. You must have a good understanding of the systems that you're working on, of course, and also a bit of a savvy intuition that sometimes things aren't always original, and sometimes there could be things that have caused issues that basic common sense sometimes people don't follow, so we need to be aware of those things. For example, this wiring is the sort of thing I see unfortunately quite a lot in this job I've been doing for 27 years now. It's not always the fault of the manufacturer, it can sometimes be someone 5, 6, 7, 8 years ago. Time, corrosion, moisture, these things suddenly break and then you have all these issues. So let's look at the next step, let's scope it, see if we've got a pattern. Let's look at Autologic, try and fix the car today.
So thankfully we've now got a good scope trace, which means the system should all be restored. Of course we need to look at the fault codes now in our next step and erase that. But that's pretty much, this scope doesn't give a huge resolution compared to say a Pico scope, but it's a good scope, I enjoy using it. It's an AVL test scope. What we're looking for is that exact image. As you could see on the earlier image, our red CAN signal was present, but it was kind of sawtoothed, it wasn't quite perfect. As I suspected, we only had one broken wire, but because of the resistor in there, and being sort of an open circuit on that wire, we can't balance the signals correctly. That's the whole point of having a terminating resistor in any CAN bus, is to balance the signal and to reduce noise and interference. And you can read more about that on the internet. There's lots of excellent repositories about CAN bus, how it works. The job today really is just to show how we find these faults and how we find them quite quickly. That, you know, we're not messing around, spending hours and hours and hours doing things and guessing and changing expensive control units, for example. That control unit could cost over €1,000 maybe. And we don't want to do that. What we need to do is we need to see what is it doing, what is it not doing that it's supposed to be doing. And by using things like oscilloscopes and a good methodical A to B to C to D test plan, we can arrive at these results much faster than an ad hoc approach where we're sort of jumping from point A to point Z and back to point D and etc, etc. So I'm very happy about that now. I could play around with this scope for quite some time to get a sharper definition, to get a better signal. I could even slow that signal down if I wanted to do. And we can pause the signal, of course, if we want to look at this in depth. We can freeze frame it like that. And as you can see, actually something that I really like to point out here. Always a bus signal should be an absolute reverse image of itself. So if we take, for example, let's take this peak here, this voltage peak. It's identical to that voltage peak there, pretty much. And if you bring them together like this, there'll be an absolute mirror image of each other. That's what you're looking for in a bus system. You have to be completely sort of synchronous. And that's an excellent bus image. It's a little bit of a peak here. I'm not too. I mean, we can even go into that and we can measure these voltage peaks. It's not really something I need to do today because we know we've just. What we can't do, because we don't have manufacturer data, is we cannot decode each frame with what that means. All we can say with certainty, with great certainty, is that we have a mirror image bus and we have basically a good bus signal, which means we should have a good bus. Now, the proof is now in the test that can we erase the fault codes on Autologic and do we get any fault codes coming back? And crucially, what's more important than anything else, have we now got communication with PDC, park distance control, and more important than that, have we got communication with the junction box electronics? I think we have, because our wipers have now stopped working and they actually work from the switch as normal. Now the fuse has been put back in. So fingers crossed, because I don't want to spend even more hours diagnosing something. Generally I like to keep things between an hour and 3 hours diagnosis and fixed time, which hopefully we've achieved on this job. So let's go and look at the fault codes and hopefully build the car up from there.
So we have our ignition on, yeah, just checking the battery support still on, of course. We're going to go into this again and start from the beginning. What we'll do basically, I think we'll erase the fault codes. So yeah, we could do a quick test again, I suppose. It's a quick test, it's quite quick actually compared to ISTA, for example, which is the BMW test at ISTA Next, what we also have here, which incidentally we do use actually quite a lot, especially for programming, although we can program with Autologic also. I would say they're both as useful as each other, but this, when you really need to do something fast and you just want to get something done and erased and check that there's no other faults coming back, this is probably the better choice, I would say. It's quite quick if you think it's checking all the control units on the car, so let's just quick clear everything. In the next step, all fault codes will be cleared and the timeline will be cleared, so that's a good point actually. If you do have Autologic, or if you have something, even an inexpensive tester that can at least show a timeline, and you haven't fixed something, it's important to always take a recording of the timeline, even if you can't print it, because it does give you an idea of when the fault first occurred, how many times it's occurred. If it's occurred once, it's probably in a sporadic fault. If it's occurred 40 times, it's obviously a permanent fault, so it's a good point to always look at the timeline of fault. But we'll clear that now, and hopefully we should have no issues with it. Incidentally, while we wait for this, we can look at on the wipers. There's no fluid in, we need to put fluid in for the customer. Our wipers are working, which they weren't before. Excellent. Oh, very happy about that. We've got, crucially, a junction box electronic, JBBF. It's communicating with no faults. Bark distance control, no faults. Basically, there's no faults in any unit. So basically, that's everything on the car now communicating. And the only thing we need to do now is come back out of Autologic, disconnect it from the car, and then we'll start building the vehicle up. Put some screen wash in for the customer, of course, because we need to do that. A little bit of a touch, what we always do here at Schmiedmann, always make sure those small things are taken care of. And we'll give the car back to the customer. And not bad for a round. Looking at the time, probably 2.5 hours from diagnosis start to finding the fault, to rectifying the fault, and then to obviously rebuild the vehicle, clean it and put it back. 2.5 hours, not bad, I think. Very acceptable, and most customers will be very happy to pay such a small amount. It could run into hours and hours if you don't know the systems you're working on. It's crucial to understand if you're working on BMWs on a day-to-day basis. I always say the best thing to do is take the things home with you. Read, and practice. Sometimes if you're a bit afraid of electrics, you know, you've got to get in there at the deep end. Just get in there. It takes hours. Do it in your spare time. If you want to be really good at this job, you've got to put the time in, and then you can get results like this where we can do it in less than 3 hours. So, I'm very happy about that, and yeah, I'm going to build it up now. Now take my headlamp off, which is always a relief on a hot day like that. Customer screen wash filled up, it's only a small thing, but it means a big thing. It came in with no screen wash, it goes out with screen wash in. It's much better. Plus we can also now test our wiper operation without scoring the windscreen with dry wipers. So, the job's done. Let's go and check the wiper operation, give it a quick clean inside. And hopefully that's a successful repair. So let's start the car. Looking good. Warning lights, check control messages, menu, status. Wonderful. Fuel 26 kilometers and door open, but no other messages. That's good. Finally. Our wipers are working. All that remains now is a bit of a polish. Leave the car in the condition we found it, with no fingerprints. Now it's time for some dinner.